Good afternoon. My name is Yaniv Sherson. I work with Brian Cantwell in Aeronautics and Astronautics and Craig Criddle in Civil and Environmental Engineering. And we are developing a process to recover energy from waste nitrogen. So wastewater treatment in the United States imposes a 3% load on US energy demand. Now, this is a process that could easily be net energy neutral from energy recovery from organic matter. However, the treatment of waste nitrogen imposes an energy sink on wastewater treatment. So we're trying to reverse this and get energy recovery from both organic matter through anaerobic digestion or gasification, and our process, which we have termed the CAN-DO. It's a clever acronym. You can find me later if you want to know what it is. So the two highest operational costs for wastewater treatment are aeration and biomass. So the top process, the top arrow, shows you conventional nitrogen treatment. Essentially, the bottom line is you get 2 moles of oxygen, 5 moles of electrons in reducing power. Our process short circuits this nitrogen cycle and enables a pathway for energy recovery from the waste nitrogen, resulting in reduced oxygen, reduced reducing power, and more energy recovery. So imagine, this is our vision, imagine a wastewater treatment facility that is not only net energy neutral, but net energy producing to offset the energy demand for national water treatment and actually put clean renewable energy back on the electric grid. This is our vision. The red line shows organic matter, the green line shows nitrogen. You can see the red goes to biogas through anaerobic digestion, and ammonia would be converted into nitrous oxide, which would be combusted and essentially supercharged, just like we supercharge race cars with nitrox, supercharge wastewater treatment facilities. So if you have any questions, or we'd like to do a pilot scale next year, so if anybody's interested in funding, potential funding, come find me. I'm in room number 12. Thank you.
Our next speaker is Andrea Gaines-Germain. Andrea.
Access to clean water is a basic human need. Yet in many areas of the developing world, such as India, women walk up to 8,700 miles each year to gather water that is often polluted by waste, chemicals, or arsenic and fluoride. The HTU project believes there is a clean way to provide water without the need for government intervention or community level interventions. My name is Andrea Gaines-Germain. I'm a member of the H2U project in the Design for Change labs with Bani Banerjee here at Stanford University. Our study area is Bangalore and the rural areas surrounding Bangalore. Bangalore receives enough rainfall each year to provide families drinking water, yet this rainwater isn't harvested. We want to increase diffusion of rainwater harvesting techniques by leveraging the aspirational influences and aspirational desires of rural villagers in India. In order to do this, we've designed or are working on designing a rainwater harvesting system that provides in-house running water. If you're going to provide running water in a home, you need a pump. So what we're doing is developing a low-cost, solar-powered pump that can be off the grid. We're looking to pump small volumes of water, about 1.5 milliliters per second, so that during the solar influence during the day, we're able to pump a family's water needs for that day. We want our system to be very reliable, simple to use and maintain, and affordable at the income levels that are in our study area. My poster will be set up near the food, so please come and ask me some more questions. I'd be very happy to discuss the project with you. Thank you.
Our next speaker is Alexandra Lipsy-Ray. Alexandra?
So my name is Alexandra Lipsy-Ray. I'm also working with Bani Banerjee on a different project at Design for Change Labs. You may have heard Bani speak about the importance of design and a human-centered process when we're looking at all of these new materials and actually putting them in place effectively. So my background is in architecture and civil and environmental engineering, and we all have found that not only do the systems that we design not perform as we expect, but people don't interact with those systems the way we expect. So we're providing a very different approach to this in the ARPA-E Behavioral Change Initiative. This is a multidisciplinary, multi-project initiative that's funded by the Department of Energy, and I'm working on the novel interactions team. The Novel Interactions team is actually developing Facebook applications, so we're leveraging a totally new platform to design a new way for people to interact with their electricity consumption data. We've developed three different applications, only 2 of which are shown here, and we're focused on 3 different motivational clusters: social, cognitive, and affective, and I can explain those more if you would like to speak with me afterwards. In sum, we're very excited about the potential this has, and we'll be launching the applications live in March of 2012 and scraping users' residential electricity data from their PG&E meters to measure how effective these applications actually are. Thank you.
Thanks, Alexandra. Our next speaker is Sean Liu. Sean?
Hi, I'm Chong Liu, a PhD student from Material Science and Engineering, Professor Yi-Sui's group. Here I'm going to present our work on conductive nanotextile for water filtration and microbial fuel cell, one material for 2 applications. And both energy and environment are our focus. We want to use an energy efficient way to deal with environmental problems, and we want to harvest energy from environmental waste. So we designed this material for water filtration, water disinfection, and also microbial fuel cells. This material is made from very robust and cheap cotton textile, and the synthesis process is very easy. It's just by deep coating and drying process, and this is very easy to be scaled up. The material has a very large surface area and very high surface to volume ratio, and it can enhance the contact with microorganisms, and then the application performance will be enhanced. After the coating with carbon nanotube ink, and this material is done and is ready for use. If you want to know more about the performance, I would like to talk to you in the poster session. Thank you.